Hey there, everyone. Let's talk about the law of cosines today. So, law of cosines. We said that we would use the law of sines, when we had side, angle, side, 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 side. No, not that one. Sorry. We would do this when we had angle, side, angle, 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 side, and even uh, side, side, angle um, are times when we would use law of cosines. We always need an opposite angle side pair. So if I have a triangle like this one, and I know that this is 40 degrees and this is 12, then this is a situation where I can use law of sines because I have an opposite pair. I have an angle and I have the side across from it. If I had something like this, 10 and 40 degrees, I have a tough time using law of sines because I don't have any opposite side angle pairs. I don't know that side length, I don't know that angle, I don't know that angle, and I don't really have a way to find those. So we're going to need another tool besides law of sines. And this tool is law of cosines. Law of cosines works wonderfully when we're given three sides or when we're given side angle side. So that last case that I just drew, where I had 40 here and 12 and 10, this is side angle side. We've got a side and then an angle and then another side. Or if we have all three sides, we can use law of cosines to find these angles for us. Okay? So when we did law of sines, I derived it for you. There is a derivation in the back of your textbook for the law of cosines. And you might want to look at it. I'm not going to do it here because it's rather long and involved. Instead, I'm going to say, you know, remember we have this situation, big A, big B, little b, big C, little c. Given these little letters are sides and the big letters are angles, law of cosines could be a squared equals b squared plus c squared minus 2bc cosine a. This is that side angle side case, and I see it right here. C, B, and the angle in between. And because we're doing side, angle, side, we can do that over here or over here as well. And so we could write b squared equals a squared plus c squared minus 2ac cosine b. These are always opposite pairs. Or c squared equals a squared plus b squared minus 2ab cosine c. So we can use law of cosines with any side angle side, side angle side, or side angle side grouping that we've got. Sometimes we see this formula written a different way. This is solved for a side. But sometimes we're using, especially in the case of side, 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 where I know the three sides, but I don't know the angles, sometimes we would prefer to solve this equation not for a side length, but for an angle. So I would add this to both sides. Here, we'll just do that. We'll add this to both sides. We'll have a squared plus 2bc cosine a equals b squared plus c squared. We'll subtract the a squared from both sides. 2bc cosine a equals b squared plus c squared minus a squared. And then we'll divide by all the stuff that's not cosine a. So cosine a equals b squared plus c squared minus a squared over 2bc. This is our general form, and we could do it with any of the angles. So, for example, cosine B would be a squared plus c squared minus b squared over 2ac. These are always the same. You're always subtracting the side across from that angle. Okay? And as a result, we could have cosine c equals a squared plus b squared minus c squared over 2ab. You can feel free just to use one of these forms, but I agree. If you have the capacity, it's a little easier if you know the one that helps you more readily or easily find what you're looking for. So let's take a look at how do I use law of cosines. So here's a situation where we've got, again, we're given three pieces of triangle information, 20, 30, and 60 degrees. So I've got this triangle here with 30, 20, and 60 degrees. Let's say that this is little a, this is big B, and this is big C. And we need to find these other things. We don't have an opposite side angle pair, so we can't use law of sines. So we're going to have to use law of cosines. And I recommend using law of cosines to find that first. Okay? So, because this is our side angle side situation. So I can say a squared equals 30 squared plus 20 squared minus 2 times 20 times 30 cosine 60. Okay, so that's 900 plus 400 minus 1200 cosine 60. Now, I want to say something about this step. People sometimes do 1300 minus 1200 is 100 times cosine of 60, and that's very much pool noodle. This is attached to that, and PEMDAS says we've got to do that multiplication before we can do any adding and subtracting. So I will say that a squared is 1300 minus 1200, and we know the cosine of 60, or we could look something like that up on our calculator. That's 1/2, and so we end up with 1300 minus 600, or 700. And if I take the square root of both sides to get a by itself, I see that a is somewhere around here. There's a calculator. There it is. That a is the square root of 700, or 26.458. So that's how big A is, 26.458. Now we've got three sides, and we do have an angle side pair. Some people like moving to law of sines at this point. I'm not going to, and I'll explain why. I'm just going to find everything with law of cosines right now. Let's find angle B next. We know that cosine B would be, cosine of B would be a squared, 26.458 squared, plus 20 squared, minus 30 squared, over 2 times 20 times 26.458. Okay, so remember, all of this stuff should be in parentheses, as should all of this when you type that sort of thing into your calculator. Can I get a light on this in a useful way? Kind of, maybe, not really. Okay. So we've got, actually, I'm going to do something, and you may not have seen this before. See that little STO button down there? STO. I don't want to type this number a couple of times, so I'm going to store that number in X and hit enter. That way, anytime I want this number, I just have to type in X. So I want that number squared, so I'm going to type X squared. Actually, I'm going to start with a parentheses, and then X squared plus 20 squared minus 30 squared, close those parentheses, divide by 2, open parentheses, 2 times x times 20. Okay, and so this is cosine of b. Let me check my mode. I see that I'm in radians, so I'm going to switch over to degrees and say inverse cosine of Earth, inverse cosine of that answer, and I get that big B is 79.19719, sorry, 179.107 degrees. Great. And now 79.107 degrees. What about big C? Well, I could use law of cosines again. Cosine C equals 26.458 squared plus 30 squared minus 20 squared over 2 times 30 times 26.458. However, I know that the angles of a triangle in Euclidean space add up to 180. And I've got two of them, so I'm just going to subtract those two angles from 180. 180 minus 79.107 minus 60. And I end up with 40.893 degrees. Okay, and so we've solved the triangle, and that's what you're going to see a bunch of in the homework. Solve the triangle using the law of cosines. And we didn't need to do this one. We really only needed to use law of cosines twice. We'll definitely, when we have side, 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 or side, angle, side, we'll have to use law of cosines at least once. And then we'll either continue one more time with law of cosines, or we'll switch to law of sines. I used to be a fan of switching to law of sines, and then I ran into a problem. Let's take a look at that problem. Okay, so we've got a similar side angle side situation where A is 15, B is 10, and big C is 45. Okay, and so we'll use law of cosines. 10, 15, and 45 degrees. This is little c, this is big A, this is big B. So what would law of cosines have us do? Because we've got side angle side here, we're going to look for this one first, the side that's opposite the angle we're given, and we would say c squared equals 10 squared plus 15 squared minus 2 times 10 times 15 cosine 45. So that's 100 plus 125 minus, that's 150 times 2 is 300, and the cosine of 45 is root 2 over 2. So these would cancel, and I get 150 root 2. I get 225 minus 150 root 2. That's c squared. Okay, 220. Yeah, I think I did that right. Let's see. 225 minus 150 square root of 2. And so I get c squared equals 12.867. If I take the square root of that, oh, that's 225. My bad. So this is 325. Okay. I knew there was something not seeming right about that. 325 minus 150 square root of 2. And I get 112.8679656. But I don't want c squared, I want to know what c is, so I'm going to take the square root of this answer, and I get that c equals 10.624. C equals 10.624. Okay, let's finish this off with law of cosines, just so we know what the actual answers are supposed to be. We can find this one next or this one next. So we know that cosine B would be 10 squared plus 10.624 squared minus 15 squared over 2 times 10 times 10.624. Okay, and this time I really want this 10.624 number as my x, so I'm going to store that answer. No, I'm going to store that answer in x. Okay, so that's x, right? So I touch x, and oh, there it is. So now I'm going to type in 10 squared plus x squared minus 15 squared, and then I'm going to divide that by 2 times 10 times our 10.624 number, and I get negative 0.057, but that's cosine of b, so I need to do the inverse cosine of negative 0.057097657. Okay, inverse cosine, and lo and behold, I get 93.273 degrees. 93.273 degrees. So 93.273, and we can subtract these two angles from 180 to find our missing one. 180 minus that 93 degrees minus the 45 degrees, and I get 41.727 degrees. Great, and so these are the solutions. We can use law of cosines just fine, but some people like, after they find that first thing, you're always going to have to use law of cosines once, so we'll find law of cosines. We'll use law of cosines to find that first piece, that first element, so that we have an angle-side pair. We've got that. And now let's try switching to law of sines. Because we have an opposite side angle pair, we could use law of cosines. Okay, I'm sorry, law of sines. So let's see what happens. Sine of 45 over 10.624 should equal sine of 93.273 over, oh, I don't know this one yet, sorry, sine of b over 15. Okay, so if I multiply both sides by 15, I've got 15 times the sine of 45, and then I want to divide that by our x value that we saved, and I end up with sine of b equals 0.998. If I do the inverse sine of both sides, I end up that b equals 86.726 degrees. Well, take a look. Is it? No, it isn't. How awkward. Going from law of cosines and switching to law of sines doesn't always work. I mean, if instead of finding b first, you had gone and found a first. Let's try that. Sine of 45 over 10.624 equals sine of a over 10. And so then we'll find 10 sine 45 over 10.624 equals sine of a. And when I do that on my calculator, 10 sine 45 divided by our x value, and then the inverse sine, I get 41.727 degrees. And look, that one is correct. So here's the thing about switching to law of sines. If I want to switch to using law of sines after starting with law of cosines, then I have to be careful about which angle I find first. Huh, what do we know about these two angles? Well, this is the smaller one. And when I find the smaller one first with law of sines, then I can subtract the two angles I found from 180 and correctly get this one. But if I switch from law of cosines to law of sines and find the bigger of the two angles, I'm probably going to be finding not my angle, but the supplement to my angle, because we're kind of creating that side-side angle situation with two different solutions. So that's something to watch out for. Because of that, many students decide, well, maybe I'm not going to switch from law of cosines to law of sines. So if you want to switch from law of cosines to law of sines after finding one opposite side angle pair, fine, then let's change colors for this, you must find the smaller angle remaining first. In fact, let's put that in green as well. Okay, so we've got to find that smaller angle. We have two angles to find. We want the smaller one first. How do we know which one is smaller? Well, across from the smaller side is the smaller angle. Which side is smaller? The 10 is, so we need to find that angle first. Okay, so law of cosines twice always works. Law of cosines switching to law of sines works if you find the smallest angle first. And that's true for side angle side. But what about side side side? So what if A is 10, B is 20, and C is 15? Okay, we've got 20, we've got 15, and we've got 10. So this is A, this is C, and this is B. Okay, so we don't have a side angle pair. Let's use law of cosines to find a side first. So this one, we know that cosine of A would be 20 squared plus 15 squared minus 10 squared over 2 times 20 times 15. So that's going to be 400 plus 225 minus 100 over 600. And so I get 625 minus 100 is 525 over 600. That's what the cosine of A is. So when I do the inverse cosine of both sides, inverse cosine of 525 divided by 600, I end up with 28.955 degrees. So we know that this is 28.955. And we could at this point switch to law of cosines, but I'm sorry, to law of sines, but I want to actually find out what the actual answers are supposed to be. And to guarantee that at this point, I need to use law of cosines to find one of these other angles. So how about C? We know that cosine of C would be 10 squared plus 20 squared minus 15 squared over 2 times 10 times 20. So that's going to be 100 plus 400 minus 225 over, this is 200 times 2, or 400. 500 minus 225 is 275 over 400. That's the cosine of C. And so C, inverse cosine of 275 divided by 400, I get 46.567 degrees. 46.567. And if I subtract these two angles from 180, 180 minus the angle I just found, minus the 28.955 that I found earlier, I end up with 104.478 degrees. Okay? So those are the actual answers. So now let's try some experimenting. Now that we know the actual answers, we're going to have to always use law of cosines at least once. And so we used law of cosines with our given side information, and we found A. So if we start with A, we found A to be 28.955. Okay, so let's go from here, having found this angle. Now let's switch to law of sines, because we've got an opposite side angle pair. Okay, so we can say the sine of 28.955 over 10 equals the sine of b over 20. That would help us find this angle. And we could do the sine of 28.955 over 10 equals the sine of c over 15. Well, let's solve these and see what happens when we do. This one, 20 sine 28.955, 28.955 divided by 10. Don't forget to do the inverse sine of that answer, and I get that B is 75.522 degrees. Hey, no it isn't. So switching the law of sines didn't work there. What if I had found this one first? Okay, so then that would be 15 sine 28.955 over 10 equals sine of C. So we could do 10 sine 28.955 divided by 10. Oops, that's a 15 on top. And don't forget the inverse sine of that. And I end up with C equals 46.567 degrees. And that is correct. Huh. So let's see. This one didn't work, but this one did work. Okay. So I guess I could use law of sines to find an angle. Use law of cosines to find this angle. And then, if I found this one first, I'd be correct. So but what if instead of finding A first, because remember we were looking at side here, and what if instead of finding A first, we had found some other angle first? What if we had found C first? So we know that cosine of C equals 10 squared plus 20 squared minus 15 squared over 2 times 10 times 20. And we came up with C equals 46.567 degrees. What if we switch now, because now we have this opposite side angle pair, what if we switch now and use law of sines? Okay, so that would be sine of 46.567 degrees over 15 equals the sine of A over 10, or the sine of 46.567 degrees over 15 equals the sine of B over 20. Let's see if either or both of these work. So 10 sine 46.567, close those parentheses, divided by 15 equals 0.484. If I then do the inverse sign, I end up with A equals 28.955 degrees. That's great. And over here, 20 sine 46.567 divided by 15. Don't forget to do the inverse sign, and I get that B equals 75.521 degrees. Hey, look, this one is not correct. How unfortunate. So I found this angle, and then this one was right, and if I found these two, I could subtract them from 180. But how do I know that I'm not finding this one and getting the answer wrong? Just because I find this doesn't mean it's correct. I only knew it was correct because I pre-did the problem completely with law of cosines. So let's check our last option. What would happen if we started with B, the biggest angle? And so we would say cosine of B equals 10 squared plus 15 squared minus 20 squared over 2 times 10 times 15. And we found out that B was 104.478 degrees. I believe that's true. I'm just going to check just to make sure. 10 squared plus 15 squared minus 20 squared. And then don't forget to divide that negative 75 by 2 times 10 times 15. Remember, parentheses around everything on top and around everything on the bottom. Inverse cosine of that answer, 104.4775. Yes, 104.478. So I've got this, and now I switch to law of sines. So the sine of 104.478 over 20 should equal the sine of A over 10, and the sine of 104.478 over 20 will equal the sine of C over 15. So we'll compute each of these. 10, well, actually, I'm going to store that angle. Store, no. Second answer, store as x. Okay, so I want the sine of x, close parentheses, divided by 20 times 10. Don't forget to do the inverse sign of that, and I get that A equals 28.955 degrees. And then over here, if I do 15 sine of x, close parentheses, divided by 20, and do the inverse sign of that, I get 46.567 degrees for C. And guess what? Both of these are correct. So, in two of the cases we did, both angles weren't correct. One was correct, one was not correct. So, but in one case, both angles, when we switched to law of sines, were correct. And what was the difference between those cases? Well, in this last case, we found the largest angle first. So, if you're using side, 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 then use law of cosines to find the, and let's make this a different color, largest angle first. Or then you can safely switch to law of sines. So we remember law of, if we have side, 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 we find the largest angle first. But if we have side, angle, side, after using law of cosines, and we can only ever find the opposite side to find opposite side, then switch to law of sines, but find the smaller angle first. Now, I'm dyslexic, and so I mix stuff like this up all the time. I don't see the big deal in just using law of cosines twice. The law of cosines twice is always going to work. It's always going to give you the right answer. So I would encourage you to do that. Okay, so that's law of cosines for us, and a cautionary note about those people who like switching. You can switch, you just have to be careful about switching. Um, I put some problems in the homework that deal with parallelograms, and I just want to go over some properties of parallelograms first. So parallelogram, we know that it has two pairs of parallel sides. So we know that this side and this side are parallel, and we know that this side and this side are parallel. We also know it has two pairs of congruent sides. So we know this is equal to this, and we know this is equal to this. We know that opposite angles are congruent. So this angle and this angle are equal, and this angle and this angle are equal. We know that no. I'm going to say, well, I kind of want to call them same side. These are on the same side. These are on the same side. Same side. I think our book calls them adjacent, but I don't really feel comfortable with adjacent. These are considered adjacent because they share a side. Adjacent angles are supplementary. We know that this angle plus this angle will be 180, and this angle plus this angle will be 180, and this one plus this one will be 180. Okay, what else do we know? We know something about the diagonals. Now, this length is a lot longer than that length. So it's not that the diagonals are equal to each other. What we know is that the diagonals bisect each other. So this and this are congruent, and this are congruent. And notice when we draw in these diagonals, we see lots of little triangles. You know, we've got this one over here, and it's, by the way, congruent to this one over here. But we also have these here. And the last thing I want to remind you about when we do this, see this problem in the homework, is this angle over here and this angle over here. These are a linear pair. They're going to be supplementary. So let's say, for example, you use law of cosines with this side, and this side. You could then find this angle with law of cosines, and because these are a linear pair, we know they're supplementary. You could find this angle by subtracting this angle from 180. And now once you're over here, if you knew this side, then this side must be the same, and you've already knew this side, so now you've got side angle side, and you can find that side. So we can use our knowledge of geometry along with law of cosines to find all kinds of sides and angles in parallelograms. And you'll see a couple problems like that in the homework as well. In our next video, we'll practice some law of cosines, and I'd like to look at a volume problem or two. In fact, I think I just want to practice a law of cosines problem now. No, I didn't. Excuse me. I'll let you practice them, and we'll save our practicing for the next video. I'll see you there, and I hope assignment number 60 goes well for you. Have a great day, everyone.